how they change. The go zone increases. So the go zone gets bigger if the yellow light time increases. And this makes sense, right? If you let the yellow light time go on for a little bit longer, you keep the light yellow for longer, then more people can get through that intersection safely. It increases, the go zone increases, if speed increases, because cars can go further in the same amount of time. That's a really bad typo, I'm sorry, so just listen. The go zone will increase if you increase the speed limit, because cars can travel a greater distance in the same amount of time. The go zone will get smaller if the width of the intersection increases, because the car has to go a further distance at the same time. So if we take an intersection like this and we make it twice as large, now we have a smaller go zone, because the car now has to get all the way through this, because you're not safe from that intersection until you get to the very other side and you're on the road traveling. Other variables, braking acceleration and reaction time, do not affect go zone. Number one, cars don't brake while they're going through an intersection. So if you're braking through a go zone, then you're probably in trouble. Probably going to end up in the middle of the intersection. And if you are having to decide to use your brakes, then again, by the time you hit that go zone, it's usually too late. For me, I like to think of when I'm driving in the go zone, a lot of the intersections will have turning arrows. So if there's a special turning lane, then you'll see these turning arrows. And when the turning arrows start, a lot of times, not every time, but a lot of times that's roughly the go zone. So for me, if I get to one of those arrows before the light turns yellow, then I'm just going to go. That's my decision made for me. Anything before that, then I kind of have to make a judgment call. And that judgment call involves, how fast am I driving? Can I come to a stop relatively soon without slamming on my brakes? The stop zone will get smaller if the speed limit gets smaller, because it's easier to stop at a slower speed. Braking acceleration increases the stop zone. Oh, I'm sorry. The stop zone will decrease if braking acceleration gets bigger, right? That's what you saw in the spreadsheet. Because better brakes mean you're going to stop quicker. And then if you change reaction time to make it smaller, then stop zone will get smaller. Because there's less time to react means you have to stop quicker. Width does not affect the stop zone, because cars in the stop zone don't ever get to the intersection. If the yellow light stays yellow longer, it doesn't matter, because if you're in that stop zone, then you should be stopping, coming to a stop. So if you're like far away from those arrows up ahead, then you're in the stop zone and you need to be coming to a stop. So it doesn't matter if that yellow light stays yellow for another quarter of a second, because you should already have made the determination that you are going to stop. Overlap zones and dilemma zones. First of all of this designing and planning by the engineers who come up with these intersections, all this stuff only works if cars follow the speed limit for each intersection. Okay, if you're speeding, then all bets are off. If you're going really slow, if you're going 30 miles an hour, where you should be going 50 miles an hour, everything changes. Okay, so going the speed limit makes the intersection safer. Now, a lot of people don't know this. The speed limit is only for sunny days. Clear and sunny days with no water and lots of light. At night, you should be going a little bit slower. In the rain, you should be going a little bit slower. There is an overlap zone that gives drivers the chance to stop or go safely. So that's right here. This would be like, maybe that first turning arrow is right here in the turning lane. So the first turning arrow is right here. So this is kind of like the overlap zone. I can go where I can stop, whatever I feel like doing. And that kind of feel is based on velocity. How fast am I moving? But if it is poorly designed, then there's a dilemma zone where you can't go or you can't stop. So if you're way back here, there's no way you're going to make it. Right here, you're not going to be able to stop. In between that, you're stuck. It doesn't matter what you do. You're either going to run that red light or you're going to be waiting. So these are poorly designed intersections. Hopefully you don't come across them too often, but they are certainly out there. Now, there are limitations to the model, things where it breaks down. So most drivers aren't aware of stop zones and go zones. They just don't know they exist. And they're left with the idea that going through the intersection is luck. Oh, I got lucky and the light stayed yellow. Or, oh, I got lucky and I made it through that intersection. I didn't have to stop. However, engineers use a model similar to the one you created in the Investigate to make the intersection as safe as possible. But not all models are perfect. This model doesn't include an ambulance coming up or a police car coming up and then everybody moving to the side and having to spread out. That changes the whole dynamics of the intersection. Definitely makes it unpredictable and not exactly safe place to be, especially if you end up being stuck in the middle of the intersection. That's not a good feeling. Or the weather, as we've learned, which has a tremendous impact on braking distance. So there's no rain piece in either of those equations. You're checking up questions. By now you should be able to know what a model is, what a stop zone is, go zone, the overlap zone, and what is meant by the dilemma zone. So for your exit ticket, you should also know what affects each of these. You'll be given the equation, but you need to know what those variables are and how to use those variables given a problem. So make sure you're doing those physics to go questions. Answer your what do you think now. That's it.